Today we are going to start talking about another newer math topic. I'm sure you've heard about it in probably 2nd, 3rd, and 4th grade, and now we're going to hear about it again in 5th grade, and that is probability. Now I hope that word rings a bell to you. When we're talking about probability, we're talking all about things that involve chance and how likely something is to happen. So let's hope that the probability of you watching this video is pretty high. Let's get started, guys.
We're going to do some practice finding the probability of some different scenarios. So Cameron has these letter cards, S-H-O-E-S, which we know spells shoes. What is the probability of picking the letter S out of these letter cards? Well, there are, let's see, 1, 2, 3, 4, 5 cards total. So we know that's going to have to be our denominator. And we're looking for the letter S. So there's one S here and one S here. So it should be 2 out of 5. Okay, where would this situation fall on a likelihood line? Your teacher will become a unicorn. Certain, likely, equally likely, unlikely, or impossible. And as bad as I hate to admit it, because you know I would love to be a unicorn, it is impossible. This is a bag of colored chips. If someone were to reach into this bag without looking and pull out a chip, what is the probability that they would pull out a yellow chip? Well, I don't know about you, but I don't see any yellow chips at all. So it is definitely impossible. All right, now a spinner, probability spinner. What are all the possible outcomes of spinning the arrow one time? Well, if I spun that arrow around one time, it could either land on red, orange, or blue. So red, orange, or blue. All right, which sentence about the likelihood of outcomes is true of this spinner? So we have another spinner here, which we know probability uses spinners all the time. We have half of this spinner circle is black, and then we have yellow, pretty big section of yellow, and then a little section of teal. So is it equally likely to land on black? Okay, well, half of it's black, half of it's other colors, so that would make sense. What about, is it unlikely to land on black? Well, considering half of it is black, I don't think it's unlikely, so we could X that one out. What about, is it impossible to land on teal? Well, it's not impossible because there's a little section of it, so that one doesn't make sense. What about, it is certain to land on yellow? Well, okay, it could land on yellow, but it could also land on black and teal, so that's not completely certain, so it has to be this one. All right, this is a bag of tiles. If someone were to reach into this bag without looking and pull out a tile, what is the probability that they would pull out a spotted tile? So here's a spotted tile, and here's a spotted tile. So we have 1, 2, 3, 4, 5, 6 total tiles, and out of those 6, we have 2. Well, if you look, there are 2 spotted, 2 gray, and 2 striped. So I'm pretty sure each of those are equally likely that we could pull out a spotted one. Okay, this is a bag of colored chips. They are all green. If someone were to reach into this bag without looking and pull out a chip, what is the probability they would pull out a green chip? Well, those are all green, so it would have to be certain that you'll get a green chip. If you choose a colored chip without looking, which is impossible to pick? Well, we know impossible means that it just cannot happen. So there's orange, there's pink, there's red, but there is no blue. So there's no way you can magically make a blue chip appear. So it has to be impossible. Okay, what is the probability of landing on a 2 when you spin the arrow? All right, well, here's the arrow, and if I spun it one time, there's a 2, a 4, a 1, a 3, and another 1. Well, there are 1, 2, 3, 4, 5 total spaces, so that has to be my denominator, so it's got to be one of these. And there's only 1 chance, so it has to be 1 out of 5. Now, I understand this says 2, okay, but that would mean that there are 2 spaces that say the number 2. And there's only 1 space that says the number 2, so it has to be 1 space out of 5 total spaces. Okay, what are all the possible outcomes of pulling a card from the cards above? So we have R, A, D, A, R. So we could pick a letter R, there are 2 of those. We could pick a letter A, there are 2 of those. Or we could pick a letter D. So we could pick a D, an A, or an R. Those are all of our possible options. Okay, what is the probability of landing on red when you spin the arrow? Okay, so we have 1 space that says red, here's another space, and another one, all of that says red. So we have 1, 2, 3, 4, 5, 6 total spaces, so it has to be one of these because 6 has to be our denominator. And we have 1, 2, 3 spaces that say red. 3, 6, which we know that if you simplify that, that would be the same thing as 1/2. Okay, where would the situation fall on a likelihood line? A new puppy will have an accident inside the house. All right, well, it's not impossible because it could always happen, and more than likely it'll probably happen. It's not absolutely certain because you might get a puppy that just for somehow knows how to go to the bathroom outside, but it is pretty likely that he's going to have an accident inside the house, just like my puppy Max did. Okay, we're going to do this one and then one more. Which sentence about the likelihood of outcomes is true of this bag of tiles? Okay, so we have a bag of tiles here, 3 dotted cards, 2 solid ones, and a striped one. So, is it impossible to choose a gray tile? Well, if I stuck my hand in there, I might pick one of these 2 gray ones, so that can't be the right answer. Is it certain to choose a spotted tile? Well, certain means that it absolutely 100% will happen. Well, I might end up picking a gray one or a striped one, so it's not certain that it has to be spotted, so that's not right. What about it is likely to choose, oh, that's a typo, just ignore that. It is likely to choose a black tile. I don't know about you, but I do not see a solid black tile in that whole thing, so that can't be it. Okay, it is unlikely to choose a striped tile. And that has to be it. Look, there's only 1 striped tile, so it's pretty unlikely because I'm more than likely going to pick a gray one or a dotted one because there's more of those, more chances. It's pretty unlikely that I'm going to somehow grab this striped one. And then the last one we're going to do, where would this situation fall on a likelihood line? Okay, Friday will come after Thursday. Well, that is 100% certain, so it has to be E.
Zoe is trying to decide on t-shirts for her band. The style choices include V-neck, sleeveless, and scoop neck. The color choices include pink, blue, white, and black. The shirts can be made out of either cotton or synthetic fabric. Zoe's starting to get overwhelmed by the options. She feels like there are a million different combinations. Let's help Zoe identify the number of different combinations she can make from these choices. Identify how many choices there are for the first category. The first category is style. The choices are V-neck, sleeveless, and scoop neck. That's 3 choices. Next, identify the number of choices for the second category. The second category is color. The color choices are pink, blue, black, and white. 1, 2, 3, 4. Now, identify the number of choices for the third category. The third category is material. There's cotton and synthetic. That's 2. Finally, multiply all the choices together. Since there were 3 choices in the first category, 4 choices in the second category, and 2 choices in the third category, we multiply 3 times 4 times 2. That makes 24 different combinations. 24 is a lot, but it's not quite a million. Wonder which one she'll choose. Multiply to find the number of combinations Sam could use to create a new masterpiece.
Alright, so if we look at this, there are 3 different categories here. The first category is paint, and he has blue paint and red paint. So that's 2 right there. Then the next category is what type of paint there are. There's oil paint and tempera paint, so that's 2 categories right there. The last category is what material it's going to be on, and that's only one option, canvas. So there are 2, 2, and 1. So we would do 2 times 2 times 1. Well, 2 times 2 is 4, and then 4 times 1 is still 4. So our answer has to be C, 4.
Yes, Sam has 4 combinations. Blue oil on canvas, red oil on canvas, blue tempera on canvas, or red tempera on canvas. Multiply to find the number of combinations of pasta dishes at Mia's track team party.
Okay, so there again are 3 categories here. We have the type of pasta, we have what kind of stuff will go in the pasta, and then we have the sauce options. So there are 2 types of pasta, so that's 2 for the first category. Then there are 3 add-ons, so that's 3 for the second. And then there are 3 sauces, so that's 3 for the third. So we would do 2 times 3 times 3. Well, 2 times 3 is 6, and then 6 times 3 is 18. So it would have to be C, 18.
Awesome! There are 18 different combinations of pasta dishes.
Summer's here and the ice cream truck is in town. The truck offers 3 flavors of ice cream: vanilla, chocolate, and strawberry. The toppings choices are walnuts, sprinkles, chocolate fudge, and cookie crumbs. Zoe only has enough money for 1 scoop with 1 topping. How many choices does she have? Let's use a tree diagram to show how many total possible combinations there are. First, list the first 3 options, which are the flavors. The flavors are vanilla, chocolate, and strawberry. Next, list the topping choices for the first flavor. Start with vanilla and make sure to draw a branch to each topping: walnuts, sprinkles, chocolate fudge, and cookie crumbs. Move to the next flavor and list each of the topping choices again. Under chocolate, list walnuts, sprinkles, chocolate fudge, and cookie crumbs. Now, add the topping choices to strawberry. Under strawberry, list walnuts, sprinkles, chocolate fudge, and cookie crumbs. Finally, add the possible combinations together by counting the bottom row of the tree diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Zoe now knows that she has 12 total possible combinations or outcomes at the ice cream truck. If it were me, I'd be all over the chocolate with chocolate fudge. My suitcase for vacation has 3 shirts, red, blue, and green, and 2 pants, jeans, and shorts. Use a tree diagram to answer how many total possible outfit combinations I have.
So he has 3 shirts, a red one, a blue one, and a green one. So that would be red, blue, and green. And then each bottom could go with that. So there are 2 bottoms. So red could have jeans, blue could have jeans, green could have jeans. So that's 3. Red could have shorts, blue could have shorts, or green could have shorts, and that's 3 more. So 3 plus 3 is 6.
There are 6 combinations. Each shirt has 2 possibilities for bottoms, jeans or shorts. 2 plus 2 plus 2 equals 6 possible outcomes.